Okay, so we're going to look at these absolute value equations that are going to involve fractions, but again, we still have a single absolute value involved. And you're going to use ideas that you've learned in previous lessons for this particular topic. But remember, the first thing you have to do is make sure that the absolute value bar is by itself. All right, so that means that I have to remove the 7 here. So right now I'm adding 7. The opposite is to subtract 7. And so I get the absolute value of 4 plus 3x divided by 8 is equal to 2. Now again, notice you see that absolute value bars, right? Okay, now once you get to this point, and notice there's a coefficient of 1 here, so that's always what you want. You want this to be a coefficient of 1 with absolute value bar expression. Then you're going to split it apart into two equations. And so you're going to say, with that now, two equations without absolute value bars. So you're going to say 4 plus 3x divided by 8 is equal to 2. And then 4 plus 3x divided by 8 is equal to negative 2. And then you're going to solve each of those linear equations. So notice here that in this equation, both of them, for that case, the LCD is 8. So the least common denominator is 8. So what I'm going to do now is I'm going to multiply both sides by 8. And so these 8's divide out, and so you get, on this left side, you get 4 plus 3x. On this side, you get 16. 8 times 2 is 16. And then to solve this linear equation, you're going to subtract 4 from both sides. And so when I combine like terms, I get 3x is equal to 12. 16 minus 4 is 12. And divide both sides by 3, I get x to be 4. Okay? Now you can check this if you want to. So let's check this. So let me go ahead and now let me just say this. So as long as when you get to this point, if you did all this work correct right here and you get to this point, when you have the absolute value by itself, as this is positive, then you're going to get solutions. Okay? You just got to make sure you do the algebraic stuff correct. So if you want to check, you can. So let's go back to the original. Always go back to the original because you could have made a mistake in this little area here. So the original was this, the absolute value of 4 plus 3x divided by 8. You want to add 7, and you want to see if that's going to equal 9. So wherever you see the variable x, I'm going to substitute the number 4. So I get the absolute value of 4 plus 3 times 4 divided by 8. Whatever that is, I'm going to add 7, and I want to see if that's going to equal 9. Well, 3 times 4 is 12. 12 plus 4 is 16. So I get the absolute value of 16 divided by 8. Well, 16 divided by 8 is 2, and the absolute value of 2 is 2. And 2 plus this 7 does give me 9. Okay? All right, now over here you do the same thing. So let me go ahead and rewrite this since I don't have enough room. So 4 plus 3x divided by 8 equals a negative 2. So multiplying both sides by 8. The LCD least common denominator is 8, so multiplying both sides by 8, I get these 8's divide out, so I get 4 plus 3x is equal to negative 16. Subtract 4 from both sides, you get x by itself, you can subtract 4 from both sides. And so this is 0, so I get 3x is equal to a negative 20. Then divide both sides by 3, I get x to be a negative 20 thirds. Okay, so those are your two solutions, so x equal 4 and x equal negative 20 thirds. All right, so it's number 1. Let's look at number 2. Let's look at another one that has fractions in it. So number 2, we have, all right, number 2, we have the absolute value. Actually, this does not have fractions in it, but I do want to mention something about it. It looks like this. So you could see something like this where inside the absolute value bars you have parentheses. No big deal. You can deal with that. So those absolute value bars went here, then you would distribute, right? Same idea. So I have the absolute value. If I distribute here, I get 3x minus 6. The absolute value, that see how this becomes 3x minus 6? Minus 8 equals negative 5. And then you want to get the absolute value by itself, the absolute value expression by itself. Good thing here is that that's a 1 here. So you're going to add 8 to both sides, and that's 0. So you get the absolute value of 3x minus 6 is equal to 3. Now remember our discussion in the previous lessons. When you get to this point where the absolute value is by itself, and that's a 1 here, if that's positive, then you're going to get solutions. If that's negative, you're going to say no solution. Remember that? Okay, because the absolute value, remember the absolute value of whatever you substitute in for x here, that's going to be positive. So this is always going to be positive. A positive is never equal to a negative. So if this was negative, you would say no solution. You saw that in previous lessons. But since that's positive, I'm going to get solution, so I'm going to split it apart. 3x minus 6 equals a 3. 3x minus 6 equals a negative 3. So you rewrite the expression that's inside the absolute value bars, and you can say 3 and a negative 3. Because remember, in our lessons, we talked about the absolute value measuring the distance a number is from 0. So 3 to the right, 3 to the left. So positive, negative. Notice I have two linear equations, so I can deal with that. So I'm going to add 6 to both sides. So I get 3x equal 3 plus 6 is 9. Divide both sides by 3. One of my solutions is 9 divided by 3, which is 3. Over here, add 6 to both sides. And then combine like terms. I get 3x equals negative 3 and a positive 6 is 3. Divide by 3. I get x to be 1. All right, so those are your two solutions, 3 and negative 1. And you can check. Let's check one. Let's just check one of them. So we're going to go back to the original, which is this. Always go back to the original because you could have made a mistake anywhere along this process. So we have 3 times x minus 2, absolute value of that, subtract 8, and that's going to equal negative 5. So in place of x, I'm going to substitute 1. So I get the absolute value of 3 times 1 minus 2, absolute value of that. Well, 1 minus, and don't forget we're subtracting 8, and I want to see if that's going to equal negative 5, right? So 1 minus 2 is a negative 1. So I get 3 times a negative 1, absolute value of that. Well, 3 times a negative 1 is a negative 3. And the absolute value of negative 3 is a positive 3. Well, 3 subtract 8 is equal to a negative 5. That's a true statement. All right, so that was number 2. Number 3, we have this for number 3. We have 3 minus 3/4 x. Oops, x, that's an x here. That's an x. Well, let me go ahead and rewrite this over. The absolute value of 3 minus 3/4 x, the absolute value of that. And then I'm subtracting, I'm adding 3 rather, and then that's equals 7. All right, so again, notice I have fractions involved. So I have to isolate the absolute value expression by itself. So I need to, in this case, since I'm adding 3, the opposite is to subtract 3. And so I get the absolute value of 3 minus 3/4 x is equal to 4. And again, notice our discussion. The absolute value expression by itself, that's a positive number, so I can split it apart. So I'm going to say 3 minus 3/4 x equals a positive 4. 3 minus 3/4 x equals a negative 4. Okay? And then a couple more steps and you're done. So what I would do here, first of all, before you multiply both sides by the LCD, let's go ahead and subtract 3 from both sides, because notice what happens. 3 subtract 3 is 0, so I get a negative 3/4 x is equal to, and 1 subtract 3 is 1. Okay? Now let's get rid of this 4 first. So right now I'm dividing by 4. Remember the LCD is 4, so multiply both sides by 4. These 4's divide out, so I get a negative 3x is equal to 4, and then divide both sides by negative 3, you have your solution. One of them at least, negative 4/3. Okay? Over here, do the same thing, subtract 3 from both sides. I get negative 3/4 x is equal to, this time, a negative 4 and a negative 3 is a negative 7. Okay, multiplying both, let me go and rewrite this over. And then, remember, I'm going to get rid of this denominator, so multiply both sides by 4. Just like that, these 4's divide out, and you get negative 3x is equal to negative 7 times 4 is a negative 28. Divide both sides by negative 3. I get negative 3 divided by 3. Negative 3 is a positive 1. 1 times x is x. So I get x to be, now remember, a negative divided by negative is a positive. And then reduce if you can. I cannot reduce this, so you're going to say 28/3. All right. Now, in both cases, if you want to write both cases as a mixed number, you can. So you could say negative 4/3 is negative 1 1/3. And then negative 28/3, 3 divided to 28 is what? 9. 9 times 3 is 27. Remainder 1. So you get 9 1/3. Okay? So either one of those is fine. All right, let's do one more with and this one's going to have a fraction in it, so let's do one more like that. So this is number 4. So number 4, we have the absolute value of 1/3 minus 3/2 x minus 6 equals a negative 2. All right, so again, I have to isolate the absolute value by itself. So I get, in this case, I have to add 6 to both sides. Do the opposite. These come out to be 0 when you combine like terms. So I get the absolute value of 1/3 minus 3 halves x is equal to negative 2 plus 6 is 4. And again, notice the absolute value is equal to a positive number. So I'm going to get some solutions. I'm going to break it down to 2 equations without absolute value bars. So I get 1/3 minus 3 halves x is equal to 4. 1/3 minus 3 halves x is equal to a negative 4. Okay. All right. Now at that point, what I would do here, since I have several terms that has fractions in it, I would just go ahead and find the LCD like we did in a previous lesson. So the LCD in both cases, this side and that side, is 6. So let me remind you what you did. So this is what you did. So you said, I'm going to multiply this side by 6 and multiply this side by 6. Remember that? And then you distributed. And so you said 6 times 1/3 minus 6 times 3 halves x equals, and then that's 24. And then you reduce. 3 into 3 is 1, 3 into 6 is 2, so this right here becomes 2. Subtract. 2 into 2 is 1, 2 into 6 is 3, and then 3 times 3x is 9x, equal 24. And now notice you have a linear equation without any fractions in it. So you got to get x by itself, so let's subtract 2 from both sides. This is 0, so I get negative 9x is equal to 24 subtract 2 is 22. And then divide both sides by negative 9. I get negative 9 divided by negative 9 is 1. 1 times x is x, and you get negative 22 divided by 9. All right, let's do this one. So let me go ahead and rewrite this a little bit further out here. 1/3 minus 3 halves x is equal to negative 4. So again, the LCD is 6, so let's go ahead and multiply both sides by 6. Now remember, we put parentheses here because you had more than one term. You had 2 terms here. Here I don't need parentheses because it's just a negative 4. Now though, remember you got to distribute now. So you're going to say 6 times 1/3 minus 6 times 3 halves x is equal to a negative 24. Okay? Now I want you to notice that this side here, that's on this side, is going to look like this. Okay? The only difference is that this is a 24, this is a negative 24. So you see how this looked like this, and this looks like this? Same thing. 3 to 3 is 1, 3 to 6 is 2. 2 times 1 is 2. See this 2 and this 2? Same thing. So this left side, all these are going to be the same. Minus, and then 2 to 2 is 1, 2 to 6 is 3, 3 times 3x is 9x. So you see 2 minus 9x, 2 minus 9x. The only difference is the right side. Positive 24, this is a negative 24. And just like you did here, remember how you subtracted 2 from both sides? You're going to do the same thing. Subtract 2 from both sides. Now this is where it's going to differ. Also, this is 0. 0 subtract 9x is a negative 9x, just like you had here. But this time, you got to be careful. A negative 24 and a negative 2 is a negative 26. Then divide both sides by negative 9. I get negative 9 divided by negative 9 is 1. 1 times x is x. I get x to be a negative divided by negative is a positive 26 divided by 9. And you cannot reduce that, so that's your answer. Okay? So that was some more examples with absolute value bars. But most of these problems involve fractions, and that's how you deal with it. All right, so that's the end of this lesson.